Hello dear ones, welcome to maths class. Today we are going to do the last problem in page number 114, question number 6. Okay, question is, a regular pentagon is drawn with all its vertices on a circle. Okay, here we have a circle and a regular pentagon. What do you mean by a regular pentagon? Regular pentagon means a five-sided polygon with all its angles and sides are equal. Okay, so here we have a regular pentagon like this. Okay, a regular pentagon. So suppose this is the center of the circle and we can divide this pentagon into 5 triangles like this, right? Then what will be the sum of central angle? Yes, we know that the sum around the center of a circle is 360 degree, right? 360 degree. And what about each of these angles? Yes, each of these angles is equal to 360 divided by 5, right? All angles are equal because this one is a regular pentagon. In a regular pentagon, all angles and all sides are equal. So, the central angle is equal to 360 divided by 5. What is 360 divided by 5 in 36? 5 times. And in 10, 2 times. So, that is equal to 72 degree. Okay, so one such triangle having the side angle 72 degree. Okay, so I am here going to take only one such triangle. Okay, no need of all this triangle. We need length of one side of this triangle. Okay, length of one side of this regular pentagon. Length of one side of this regular pentagon. So here we have the radius of the circle is 15 centimeter. Okay, which is the radius here? Yes, this one is a radius. Similarly, this is also a radius. Okay, then using the property 2r sin c by 2, can we find out the length of this side of the pentagon? Is it possible? Yes. Yes, what is 2r here? Yes, 2 into r. What is r? R is the radius of the circle, that is equal to 15. And sin c by 2. See, this side of the pentagon is actually a chord of this circle, right? So, length of the chord is equal to 2r sin c by 2, where c is the central angle of the chord. Here, what is the central angle of the chord? That is equal to 72. Then which is equal to sin c by 2. C is 72 by 2. Okay. So 72 by 2, that is 2 into 15 into 72 by 2 is equal to 36. So we have sin 36. Okay. Value of sin 36 is 0.5878. Okay, sin 36 is equal to 0.5878. Substitute the value in this equation. We have 2 into 15 is equal to 30 into 0.5878. And if we multiply these two, we have 17.63 centimeter. Okay, so this is the length of one side of this regular pentagon. Okay. So that section is over. Our next topic is another measure. Okay, in the beginning of the chapter, I have told you one more measurement or one more ratio. Do you remember which ratio is that? Yes, we already discussed two ratios. One is sine and another is cos. Okay, so now we are going to discuss the third ratio, that is the tangent ratio. Okay, tangent ratio, or we take this ratio as tan ratio. Okay, what is tan ratio? So here we have a right triangle like this, and in this right triangle, if we consider this angle as x, and this is 90 degree. Okay, if this one is triangle ABC, then which is the side adjacent to x? Yes, this is the side adjacent to x. This is the adjacent side, and this one is the opposite side of this angle. See, this one is the opposite and this one is the adjacent side of the angle x. Now we have the ratio. The ratio, tan ratio means what is tan x? That is our question. Tan x is actually, yes, opposite side by adjacent side. Okay, opposite side by adjacent side is called the tan ratio. Okay, opposite side by adjacent side gives the tan ratio or the tangent ratio. So here we have, yes, what is tan x here? Yes, which is the side opposite to x? That is equal to AB. Okay, and which is the adjacent side? Adjacent side is equal to BC. This AB by BC is called the tan ratio of this x. Now we have the triangles. Yes, one is isosceles right triangle and another is a 30, 60, 90 triangle. Okay, so in a isosceles right triangle. In an isosceles right triangle, we know that this angle is equal to 90. These two angles are 45 each. Okay, 45 each. And we know if this side is equal to 1, this one is equal to 1. Okay, and this side is equal to root 2. And then 30, 60, 90 triangle. And 30, 60, 90 triangle, we know that, yes, this angle is equal to 90. This one is equal to 30. And this is equal to 60. Okay, then the side opposite to 30 is 1 and the side opposite to 60 is root 3 and the side opposite to 90 is 2. Okay, so now I am going to find out the tan ratio of 45, 30 and 60. Okay, what is tan 45? Tan 45, which is the side opposite to 45? Yes, if we consider this or this, both are same, right? So if we consider this angle, opposite side is this one, adjacent this side is this one. So we have 1 by 1. Similarly, here also the side opposite to 45 is 1 and the adjacent to 45 is also 1. Okay, so we have tan 45 is equal to 1 by 1, that is 1. Okay, tan 45 is 1. Now next is tan 30. Okay, what is tan 30? See, here we have 30 degree angle. So which is the angle side opposite to 30 degree? That is equal to 1. And which is the side adjacent to 30? That is equal to root 3. See children, this one is the hypotenuse. That is not adjacent or opposite side. Okay, we consider that as the hypotenuse itself. These two, the perpendicular sides are the adjacent side and the opposite side. Okay, so here the side opposite to 30 is 1 and the side opposite to 30, adjacent to 30 is root 3. So the value of tan 30 is 1 by root 3. And what about tan 60? Yes, tan 60, this is our angle 60 and which is the side opposite to 60? That is equal to root 3 and the side adjacent to 60 is 1. Root 3 by 1 is equal to root 3 itself. Okay, so we have the important tan ratios, that is tan 45 is equal to 1, tan 30 is equal to 1 by root 3 and tan 60 is equal to root 3. Okay, you should by heart these results. Tan 45 1, tan 30 1 by root 3 and tan 60 root 3. Now we have some problems as we did in the case of sine ratio and cosine ratio. We have another set of problems in page number 117. We are going to do that problems. Okay. So look at page number 117. First question. One angle of a rhombus is 50 degree. You know what is a rhombus? A rhombus is a parallelogram with all sides are equal. Okay. So here we have a rhombus. with one angle is equal to 50 degree. Okay, and the larger diagonal is 5 centimeter. Okay, suppose this is the larger diagonal. So the larger diagonal and its length is 5 centimeter. Okay, this length is equal to 5 centimeter. What is its area? This is our question. What is its area? What is area of a rhombus? Yes, we can find area of a rhombus in two ways. We can consider rhombus as a special type of parallelogram. Then we can use the area. We can use the formula BH to find the area. What is BH? BH is one side and the perpendicular height from the opposite side. But here we don't have the one side. Okay, we don't have any side here. We have only one diagonal, and we have one more equation to find area of a rhombus. What is that? That is equal to d1 d2 by 2. Okay, do you remember this equation? d1 d2 by 2, where this d1 and d2 are the two diagonals of the rhombus. Okay, d1 and d2 are two diagonals of the rhombus. So which is the second diagonal here? Yes, this one is the second diagonal here, right? So it's the second diagonal. Now I am going to name this rhombus first. That is, this is A, B, C, D, and the diagonals meet at the point O. Okay, and we know the diagonals of a rhombus are perpendicular bisectors of each other. Okay, these two are the diagonals and they are the perpendicular bisectors of each other. Perpendicular bisector means the angle between the diagonal is 90 degree. Okay, all these angles are 90 degree. Okay, so here we consider one such triangle, and also remember children, the diagonal is also the angle bisectors. Okay, diagonals are also angle bisectors. That means this diagonal divide this angle into two equal parts. Similarly, these two angles into that angle also into two equal parts. And we know that the opposite angles are equal in a rhombus. Okay, so these are the important properties of a rhombus. So we have this triangle AOB. This triangle AOB is a right triangle. Okay, triangle AOB is a right triangle. And if this AC bisects this angle 50 degree, this angle is 50 degree, then what will be this angle? Yes, this angle is equal to 25 degree. Okay, so what is our aim? We need the second diagonal of the rhombus. Okay, we need the second diagonal of the rhombus. So here we consider this triangle, this right triangle with the one angle is equal to, yes, this angle is equal to 90 degree and this one is equal to 25 degree. See, so this OA and OB are the adjacent and opposite sides of this 25 degree, right? So this is half of the diagonal, half of the big diagonal, that is this length is equal to half of the big diagonal. Big diagonal is 5 centimeter and its half is equal to, what is half of 5? That is equal to 2.5. Okay, and we need this length, right? That is half of this second diagonal. And how do we find this? See, this is the opposite side of this 25. Similarly, this is the adjacent side of the 25 degree. Okay, so opposite side and adjacent side. So which ratio is more suitable here? Yes, opposite side and adjacent side. Which ratio? Tan ratio. So what is tan 25? Yes, tan 25 is equal to opposite side by adjacent side. Opposite side is OB. And what is adjacent side? Adjacent side is equal to OA. Okay, tan 25 is equal to OB by OA. Tan 25 is equal to OB by OA. And now we need this OB. Right? OA we have 2.5. So what is OB? Yes, OB is equal to, just cross multiply this OA with the tan 25. Okay, OA is equal to, yes, 2.5. Then what is OB? Yes, OB is equal to 2.5 into tan 25. Okay, 2.5 into tan 25, and the value of tan 25 is given in the table. So just substitute that value here. What is the value of tan 25? That is equal to 2.5 into tan 25 is equal to 0.4663. Okay, 0.4663, and if we multiply these two, we have 1.165. Okay, 1.165. 1.165. Okay, and we know that this length is 1.165. And what about the length of the diagonal BD? Yes, that BD is equal to, yes, 2 times of this 1.165. Okay, 1.165. Okay, now I need to simplify now. Okay, just substitute this value in the equation d1 d2 by 2. Okay, what is area? Yes, area is equal to d1 d2 by 2. Okay, so here what is d1? Yes, d1 is equal to 5. And what is d2? Yes, 2 into 1 point, yes, 2 into 1.165. Okay, divided by 2. Okay, so we can cancel these 2 and 2. For that only I have told you, do not calculate at that time. Okay, no need of calculation in the steps. So just write 2 into 1.165 there. Then area is equal to 5 into, yes, d2 is 2 into 1.165. Just write that, 2 and 2 get cancelled. Then we have 5 into 1.165, and 5 into 1.565 is equal to 5.83. Okay, 5.83 square centimeter square. So this is the area of the rhombus. Okay children, this is very easy. Now the second question, a ladder leans against a wall. Okay, this one is the ground or the floor. Okay, and this is the wall. A ladder leans against a wall. Suppose this is our ladder. Okay, ladder. So it is leans against a wall with its foot 2 meters away from the wall. Okay, foot is, this part is the foot of the ladder. This ladder is 2 meters away from the wall. This is the wall, and it is 2 meters away from the wall. And the angle with the floor is 40 degree. Okay, this is the ground or this is the floor, and the angle with the foot of the ladder is 40 degree. Okay, 40 degree. How high is the top end of the ladder from the ground? Okay, how high is the top end? This is the top end of the ladder, and how high it is from the ground. Okay, that means we need this height, right? This is the top end, and what is the distance between the top end and the floor? That is our question. Okay, so we need this height, and we have this length, that is 2 meter. Okay, this length is equal to 2 meter, and also one angle 40 degree. Then how do we find this wall length, height? This height, here I am going to name this as points as A, B, C. How do we find the distance AB? Do you have any idea? Yes. For that, if we consider this angle 40 degree, what is this AB? AB is the opposite side. What is this BC? BC is the adjacent side. So using the ratio of opposite side and adjacent side, we can find out the length AB, right? So which is the ratio related, opposite side and adjacent side? Yes, tan ratio. So if we take tan 40, what is tan 40? Tan 40 is equal to opposite side. Opposite side is AB. So that is the height from the top, from the ground to the top end of the ladder. Okay, and BC. Then from the table we have tan 40 is equal to, value of tan 40 is 0.8391. Okay, 0.8391, and which is equal to AB by, what is BC? BC is equal to 2. Okay, now we can calculate this AB by just cross multiplying these two. That is, AB is equal to 2 into 0.8391. 0.8391 into 2 is equal to 1.68 meter. That is, the top of the ladder is 1.8 meter, 1.68 meter away from the floor. Okay, that is the answer. And here we have a third question. That third question, we did similar question in the section of sine and cos. So do that third problem as a homework. Okay, so today we are going to wind up, children. Thank you.